Lesson 1.2.2. Here for lesson 1.2.2, we're going to be taking a look at point slope form of a line and how that point slope form equation is generated, where it comes from. Most of you are used to slope intercept form of a line, so this will be a little bit new. Okay, so first let's get started here. We're going to skip this part here. We'll do some programming with a calculator in class. It's a little easier to explain. So we're going to start with number 57. We'll start by applying the process to find the equation of a line through 1, 2, and 7, 5. Using the diagram below, answer the following questions in your study team, or just answer it here from home. So what we're looking at here is finding the equation of this line. What are the coordinates of point A? So if we look at point A right here, okay, point A would have the same y value as this point, and it would have the same x value as this point. So we would say here that point A would be 7, 2. Find the slope of the line between the points 1, 2, and 7, 5. So between point A, or between this point and this point, what's the slope? We have an equation for slope. A little review here. So it's y2 minus y1 over x2 minus x1. So our slope there would be 5 minus 2 over 7 minus 1, which ends up being 3 over 6, which is 1/2. So our slope between those two lines equals 1/2. Then it's asking us, what's the coordinates of point B? So point B is over here. So x value, it'll have the same x value as this point, which is just x. Okay, but then it'll have the same y value as that point, which is 2. So the coordinates of point B are x, 2, and there's nothing wrong with that, having an x as a value there. Using the same process we used in slope between 1, 2, and 7, 5, find an expression for the slope of the line that uses the points 1, 2, and x, y. So basically we're taking 1, 2, and x, y and substituting them into the same equation for slope. Y minus 2 over x minus 1. So in other words, we're not actually calculating a slope there. We just have an equation for it because we have x and y values in there. Since the slope between any two points in the line is constant, the slope you calculate in part B and the expression we wrote in part D are equal. So if we take this expression, y minus 2 over x minus 1, and we let that equal the slope we found from part B, which is 1/2, there's nothing wrong with that. They are completely equal because the slope on this line, because it's a straight line, is equal everywhere on that line. It says here to multiply both sides by x minus 1 so that we can eliminate the fraction over here on this side. So in doing that, we end up with point slope form. Of a line. Different than slope intercept. Okay, point slope is a point and a slope. So we have the point 1, 2, we have the slope 1/2. That's point slope form. Slope intercept is slope and an intercept. That's why it's called slope intercept. Alright, so the next few problems here, just look at an arbitrary line. That means a line that doesn't have any values. So what is the final equation for point slope they give you here? Okay, two forms of it. Y minus y1 equals m times x minus x1. Or if you add this y over to get it to y equals, so you could graph it, it'd be y equals m times x minus x1 plus y1. Now, let me write something else for you that should look extra familiar here. Y equals a times x minus h plus k. So point slope form is basically the graphing form for a linear. Did you ever notice in Algebra 2 how you did parabolas, you did cubics, you did hyperbolas, you did exponentials, you did all these parent families? The one parent family you never did and never did shifts for was a line. Well, that's all it is, point slope form. Another way to develop the point slope form of lines related to the work you have been doing with transformations. That's what I just spoke about. Okay. Where slope, the m is the stretch value, and the x value will be the horizontal shift, the y value will be the vertical shift. So no real notes there. What if we have the function f of x equals mx and we shift the graph to the right h and up k? Basically what I'm doing there, or what they're trying to get you to do, is write the general equation for a linear, which you should already know because it's the same as for a parabola and a cubic and so on and so forth. Why is this called point slope? Because it's made up of a point and a slope. Compare that to slope intercept. Slope intercept. Point slope is a point and a slope. Point is made up of those two values and a slope. That's why it's called point slope. Should be pretty self-explanatory, common sense. There's a little math notes box. I would add that to your toolkit for now. Find the point slope form of the line that has a slope of 3/5 and passes through the point 10, -3. Now the nice thing about point slope is it's less work than slope intercept because you don't have to find the intercept. So y minus -3 equals 3/5 times x minus 10. So this turns into a plus. So if I isolated my y value, I would end up with y equals 3/5 x minus 10 minus 3. Okay, slope of 2.85 and goes through the point 6173 or 7.3. So we would have y minus 7.3 equals 2.85 times x minus 6.1. I don't care if you leave it in this exact form. You don't always have to add this over, okay? But if we would, it would be y equals 2.85 times x minus 6.1 plus 7.3. Okay, now again, beyond this exact lesson here, I don't ever want you to do this process by hand, ever. You know how to use the calculator, use it. Okay, now if it's asking for point slope form, that's fine. Get the slope, use one of the points to write it in point slope form. So by hand, we would have 21 minus 8 over, is that a, I'm kind of having trouble reading this, I think it's a 15. 15 minus 4, so I would end up with 13/11 as my slope. So point slope form would be y minus, choose a point, 13/11 times x minus 4. I chose the first point. Does it matter which point you choose? Absolutely not. Okay, you go ahead and try letter D. And we're back there with the answer to letter D. Y minus 6.24 equals 4.425 times x minus 4.3 is the point slope form. Here's my work for the slope, and then I plugged it into the formula. Dan knows that to find the slope of a line, did you know this, Dan? Perpendicular to another line, it's necessary to do something with the reciprocal of that slope. He wants to find the slope of the line perpendicular to y equals 2/5 x. He graphs 5/2 x on the same axis, but notices that they're not perpendicular. So he's forgetting one thing. Perpendicular lines, slope is opposite and reciprocal. So you have to flip the fraction and make it either positive or negative. So in this case, Dan should have had y equals negative 5/2 x as the perpendicular line. Flip it and make it negative. What two words describe the relationship? Slopes of perpendicular lines, just said that in last problem. Opposite reciprocals. Relationship in the previous problem is not true in one special case, and that's vertical lines do not have a defined slope. Okay? Using point slope form, find the equation line that is parallel to 3x minus 6 and passes through the point -2, 7. That's what makes point slope form so great, because parallel means same slope. So the only number I need here is the 3. So this problem involves no work. Y minus 7 equals 3 times x minus -2, which is plus 2. Done. Just like that. Okay? Just like that. All right, so second one here, same thing, perpendicular now. So I'm going to take the slope of 3/4. I'm going to flip it and make it negative. So again, no work with point slope form. Y minus 20 equals negative 4/3 times x minus 12. Done. All right, that just happened. Two more formulas to add to the toolkit from geometry: midpoint formula, distance formula. Copy them down. So find the length of AB, that's distance formula. Find the midpoint of AB, that's the midpoint formula. So I think you can do those. Plug them into the formula, get an answer, and check back when you're finished. Okay, so distance formula here, plugging in all the variables that we have, we end up with a distance of 15 between those 2 points. Midpoint formula results in a coordinate. Okay, so plugging all my numbers into the midpoint formula here, I end up with 9, 15 halves. You could have written that as 7.5 if you wouldn't have liked to. And I believe that's it for that lesson. See you on Monday.